10.3, solving radical equations. Okay, so I've got some suggestions here for ways to handle solving radical equations. So the first thing you'd want to do is isolate the radical. So you see on A here, the square root is already isolated. On B, it's not. So the first thing I'd want to do is add 7 to both sides. Okay. Once you have the radical isolated, then you'd want to square both sides of the equation. Okay, because I want to know what x equals, not what the square root of x equals. So the way I can get rid of that square root is by squaring. Those undo each other. But then I got to do the same thing to the other side of the equation. So now I have x equals, and then 6 squared is 36, and there is my solution. Okay, so you can always check your answer in the original equation. I'm not going to write that out here, but I can think, hey, plugging 36 in for x, square root of 36 is 6, so that works out. Okay, all right. Then on part B, since like I was talking about, the radical's not isolated, so first I want to add 7 to both sides, and now I've got the square root of x is equal to 10, and now I'll square this equation to undo the radical there, and x is going to equal 100. Okay, I'm not going to go through with the checks in just in the interest of time, but you could check any of these at the end, right? Okay, so here we want to get the radical by itself again. Let's subtract 15. And then 22 minus 15 is 7, and now I'll square. So now I have x equals 7 squared is 49. Okay. All right, next up. So want to get rid of this 1 first. I can do that by subtracting 1 from both sides. So now I've got negative, or the opposite of the square root of x equals negative 3. But I want to get rid of that negative symbol as well. So now you can multiply or divide both sides by negative 1. And you have the square root of x equals positive 3. Okay, and now we square, and x will equal 9. Okay, some more examples. So hey, let's get the radical by itself. I'll subtract 7 from both sides. Now the square root of x plus 4 equals 4. Some people will try to subtract 4 to get rid of that 4, but you can't do that. It's inside the radical. So before we get rid of that 4, we have to get rid of the radical. So the next step here would be to square. Okay. Now the square and the square root undo each other. So that means x plus 4 is going to equal 16. And now I can subtract 4 from both sides. And x will equal 12. Okay. All right. So got a couple things happening here. I need to get rid of the 4 and the 2. And we have to subtract 4 first. We're using PEMDAS in reverse here. I kind of think of it as just farther away from the radical, so that's the one I get rid of first. So then I've got 6 equals 2 times that square root. Now I need to get rid of the 2. It's 2 times the radical, right? It's 2 multiplied by the radical, so I can undo. Sorry, I accidentally hit stop on my recording, but okay, got it going now again. So I was going to divide by 2 to get rid of this 2 here because it's 2 times the radical. So now on the left side, I also divide by 2. So I've got 3 equals the square root. So now I've got the radical isolated. So now's the step where I'd want to square to get rid of that square root on both sides of the equation. And I have 9 equals negative 5x minus 1. Okay? So next let's add 1 to both sides. 10 is going to equal negative 5x. And last we will divide by negative 5. And let's see, 10 divided by negative 5 would be negative 2. Okay? All right. Next up, now we have 2 radicals. So these radicals are already isolated, so that's nice. So let's say I wanted to get rid of the radical on the left side of the equation. Well, I'd square, then I have to square the whole equation, which is pretty nice because it gets rid of both radicals in one fell swoop. So then 3x plus 1 is going to equal 4x minus 7. And I'm solving this for x. So I want to get these like terms together. So you could either subtract 3x or 4x from both sides. I'm going to subtract 3x just so that my x term stays positive. So 4x minus 3x is 1x. And now add 7 to both sides. And x equals 8. Okay. Same kind of deal here on this one. I'm going to square both sides of the equation. Then 3x plus 4 equals x plus 2. I'll subtract x to get those x terms together. Okay, and now I'm trying to isolate the x, so I'm going to subtract 4. And divide by 2. Okay, let's try a couple more on the next page. So I want to isolate the radical, like so. Okay, now I don't want to square both sides because it's a cube root. So the only difference here is that you would cube both sides to get rid of the cube root. So then x is going to equal 5 to the third. 5 times 5 times 5. I'm thinking 5 quarters, that's $1.25. So this would be 125. Okay. All right. And then this last one, the radical is already isolated. So next step would be to cube both sides. So that means 3x plus 7 is going to equal 10 to the third. 10 to the third, that's a 1 with 3 zeros. 1,000. Okay, then I'll subtract 7, and 3x will equal, it's supposed to be a subtraction symbol there, 3x is going to equal 993, and then I divide by 3 to isolate the x, and x will come out to exactly 331. Okay. Nothing really different with the cube roots except you cube instead of squaring. Okay. All right. So I haven't been doing the checks on these problems, but sometimes you can get answers that are extraneous. And that means it's a solution that you got algebraically, that's fine, but when you test it in the original problem, it doesn't work. Okay? So all the problems we've done so far don't have extraneous solutions, but it's probably a good idea to just to always check your answers. Okay? So I'll show you some that might have extraneous solutions now. So on this one, what I'd want to do is square both sides of the equation. This is a pretty simple one here. Okay, and then I have x is going to equal negative 2 times itself would be positive 4. Seems like a reasonable answer, but let's do a check. Okay, I'm going to go back to the original equation, and I'm going to plug in 4 for x and see what I get. Okay, now in a way this is true because there's a positive root and a negative root to 4. But when you're doing the checks, you only want to use the positive roots for square root. So I'm going to simplify this left side to 2. Okay, and that does not equal negative 2. Okay, so I'm going to write use positive roots for checks. Those are called the principal roots, okay, as opposed to the negative roots. Okay, so that one doesn't work out. That means that this is an extraneous solution. Okay, and that means that we have no solution because it's the only solution we have and it's extraneous. That means we have to throw it out. It's not a real answer. Okay, and it kind of makes sense. It is saying the square root of some number equals negative 2. Any number you plug in, at least any real number, we haven't gotten to imaginary numbers, and we won't in Algebra 1. That's an Algebra 2 concept. But any real number you'd put in, if you take the square root of it, it's going to come out positive, not negative. Okay? All right, so that one has no solution. All right, so moving on to this one. Okay, so the radical is already isolated, so I'm going to square both sides. Okay, then I've got 4 minus 3x equals x squared. Okay, so now looking at this, none of these terms are like terms. So I've got myself a quadratic equation here. Okay, so I want to set it equal to 0. I'm gonna add 3x to both sides. So then I have 4 equals x squared plus 3x, and then I want to subtract 4 from both sides. And now I've got it set equal to 0. And I can't combine any of those terms. They're not like terms, right? But I can still solve this by factoring. You could also use quadratic formula or complete the square. So I'm going to do this with a diamond problem. I'm going to put the 3 on top and the negative 4 on bottom. I'm looking for two numbers that add to 3. The same two numbers multiply to negative 4. So I'm thinking 2 and negative 2, well, that's not going to work. But I can do this with a 1 and a 4. So I'd need the 1 to be negative and the 4 to be positive. And these numbers tell me how this is going to factor. This is going to factor into x minus 1 times x plus 4. Okay? Now that it's factored and set equal to 0, I can use the zero product property. I got these two things multiplied together that equal 0. So that means one of these two pieces have to equal 0. So either x minus 1 equals 0 or x plus 4 equals 0, which means x equals 1 or x equals negative 4. Got two different solutions, and especially when you get two solutions, check them, because often one of them is extraneous. It could be that they both work or neither one works, but we want to check, okay? So I'm going to check both of these. So I'll do a check with x equaling 1. So I'm going back to the original equation. I didn't leave myself much space here, so I've got to work pretty small. So I'm thinking inside the radical, that would be 4 minus 3, that's the square root of 1. And the square root of 1, we want to use the positive root. So that means this one works. Okay, so x equals 1, that's a good answer. Let's check negative 4. Okay, I'm going back to the original equation. And there's two places to plug in for x there, right? So let's see, I have 4. Negative 3 times negative 4 would be 12. So 4 plus 12 is 16. Okay, and then I'm only using the positive root here. And that one does not work. So that means this is an extraneous solution, and you throw it out. So x equals 1 is our solution then. Okay? All right, let's try it a couple more. So I want to isolate the radical here. Then I want to square this. And I have 3x equals 81. Negative 9 times negative 9 is positive 81. Okay, let's divide by 3. And x is going to equal 27. Okay, let's do a check on that. Even though we only got one solution, let's check it. Okay, 3 times 27 is 81. And then the square root of 81 is 9. And now I have 19 equals 1. Well, no it doesn't, right? That's not correct. So that means this is an extraneous solution. It's the only solution I had going, so that means no solution. Okay, all right. Let's try one more here. So let's square both sides. Okay, now this isn't just going to be x squared plus 1 squared over there. It's not quite that simple, right? What we have after we square it, you want to think of this as x plus 1 times itself, like that. You can't just square the x and square the 1. You can't distribute an exponent like that, because when we have a binomial times a binomial, we're going to have to FOIL this. First, outer, inner, last. Okay? So first, x times x is x squared. Outer is 1x. Inner is also 1x. And last, 1 times 1 would be 1. Okay? And I can, well, on the left I still have 7x plus 15. All right, I can combine x plus x. 1x plus 1x is 2x. Okay, now I want to, I've got all this stuff happening. I want to combine the like terms. So I want to set this all equal to 0. Since there's more already on the right side, I'm going to pull everything to the right. So I'm going to be subtracting 7x from both sides, like that. I'm also going to subtract 15 from both sides. So I'll do these both in one step since I don't have a ton of room here. Okay, and I got it down to this. All right, I'm going to do a little diamond problem then. I'll just separate it like that to be clear that this goes with this problem. Okay, I'm going to factor this. So I'm thinking 1 and 14, I can't get to a 5 with that, but I can get there with a 2 and a 7. If the 2 is positive and the 7 is negative, that's going to be my winning combo. So that means this factors into x plus 2 times x minus 7. Okay? And let's see. If x plus 2 equals 0, then x would equal negative 2. And if x minus 7 equals 0, then x equals 7. So there's my two possible solutions. But wait a second, let's check them. Okay, so I'll do a checkup here for, I'll check for x equals negative 2 here, just to be clear what I'm checking. All right, so I'm going back to the original problem. Okay, let's see. I've got negative 14 plus 15, that's 1. And this would be negative 2 plus 1 is negative 1, but I'm only using the positive root. And so that one does not work. That means this is extraneous. Okay, so let's check x equals 7. Okay, plugging 7 in on both sides. So let's see, I've got 49 plus 15. And then the right side, that's 8. Excuse me there. All right, so this is going to come out to 64. And hey, the square root of 64 is 8. So that means this one works. So that's a good answer. Okay, and that's the end of the section, and I'll see you next time.